8 hours ago, something happened in deep space that should not be possible. On the 19th of February 2026, the James Webb Space Telescope transmitted a spectral data packet with only a 0.04% probability of occurring naturally inside our solar system. This was not a minor orbital shift or a routine comet flare. At exactly 14 UTC, NASA's Deep Space Network confirmed that 3I Atlas began releasing methane at a staggering rate of 300 kilograms per second. This is not frozen methane, gently evaporating like we see on Pluto. This is a sustained, forceful discharge. Picture an object 240 million kilometers from Earth, long believed to be a silent, frozen relic, suddenly activating like an industrial system. To produce methane at that rate requires an internal heat source that standard physics cannot explain. Comets do not simply switch on and release organic compounds with mechanical precision. This is not a slow leak, it is a controlled purge. When scientists analyzed the spectral lines from Webb's NIRSPEC instrument, they saw more than gas. They saw structure. The output was steady to 3 decimal places. In nature, outgassing is erratic. It fluctuates and weakens. Yet 3I Atlas is venting with the rhythm of a calibrated device. If this is natural, we are facing a new stage of comet evolution that overturns 50 years of astronomy. If it is not natural, then we are observing the exhaust of something we do not yet understand. The raw telemetry challenges our understanding of thermodynamics in vacuum conditions. At this moment, 3I Atlas is behaving less like a rock and more like a machine. To grasp the scale of this event, we must examine the timeline. Over the past 12 hours, a sequence of measurements has emerged that is not simply rare, but statistically impossible. And it begins at 9:15 UTC, when an observatory in Chile detected the first sign that something extraordinary had started. At 9:15 UTC on the 19th of February 2026, the Atacama Large Millimeter submillimeter array in Chile detected a faint but sudden thermal anomaly surrounding 3I Atlas. ALMA specializes in tracking cold gas, the faint signatures of distant comet tails, and molecular clouds. What it recorded was not a gradual buildup, it was an instant, dense cloud forming tightly around the object's nucleus. In less than 40 minutes, 3I Atlas went from 0 detectable methane to a plume stretching 4,000 kilometers wide. Comets warm slowly as they approach the sun, releasing gas over weeks. This transition happened in under an hour. NASA's Goddard Space Flight Center immediately flagged the data. Then at 10:42 UTC, the European Space Agency's Gaia spacecraft registered a micro shift in the object's trajectory. The methane release was not passive. It generated measurable thrust. Gaia calculated a non-gravitational acceleration of 0.0004 meters per second squared. That may appear minor, but for an object the mass of a mountain, it equals an explosive force comparable to 500 tons of TNT detonating every minute. At 12:30 UTC, the James Webb Space Telescope turned its NIRSPEC instrument toward the coordinates. Webb operates in infrared wavelengths and can identify chemical fingerprints with precision. The spectrum that returned to the Space Telescope Science Institute in Baltimore was clear. It was not water vapor. It was not carbon dioxide. It was pure methane. The absorption line at 3.3 microns showed a signal-to-noise ratio of 100:1. Gaia confirmed the kinetic push. ALMA verified gas density. 3 independent systems, different methods, same conclusion. A high-pressure release of organic fuel. Standard astrophysics tells us methane remains trapped within ice lattices and escapes slowly as temperatures rise. but 3I Atlas is in a region measuring minus 140 degrees Celsius, it should be dormant. Instead, it is outgassing more methane than the total volcanic output of Io, Jupiter's moon. To release methane at 300 kilograms per second demands internal heat. Where is that energy coming from? That question becomes even more urgent when we calculate what it actually takes to sustain this reaction. To convert solid methane into gas requires energy. The enthalpy of sublimation for methane is about 8.2 kilojoules per mole. When scaled to 300 kilograms per second, the object must generate roughly 150 megawatts of continuous thermal power. That is the output of a small nuclear reactor. It is enough to power a city of 100,000 people. Yet 3I Atlas is far from the sun, where solar heating is negligible. There is no external source capable of driving this reaction. Traditional comet models suggest trapped gas pockets may rupture. But ruptures are brief. They spike and fade. The data over the last 8 hours shows no decline. The release rate is flat and sustained. That implies an active mechanism rather than a single explosive event. Then comes the second anomaly, purity. Comets are often described as dirty snowballs, mixtures of water, ice, carbon dioxide, ammonia, and dust. When they vent, the output is chaotic. Spectral analysis from the James Webb Space Telescope shows methane at 99.4% purity. There is almost no water vapor, no significant carbon dioxide, no dust grains. Nature rarely produces industrial-grade chemical separation inside random rocks. Methane is a high-energy hydrocarbon commonly used as rocket fuel. If an engineer designed a propulsion or life support system, pure methane would be a logical choice. But astrophysics does not assume intent without evidence. So, researchers examined isotopic ratios. Carbon exists mainly as carbon 1,2 and carbon 1,3. In non-biological cosmic material, their ratio remains consistent. Living systems and advanced chemical processes favor carbon 1,2 because it bonds more efficiently. At 1645 UTC, high-resolution spectra from the Keck Observatory in Hawaii measured the isotopic signature of the plume. The methane was enriched in carbon 1,2 by 40% above the cosmic standard. This signature appears in biological methane on Earth and in laboratory synthesized methane. It does not appear in random comets from the Oort cloud. Now we face three simultaneous anomalies: a 150 megawatt heat source near perfect chemical purity and a carbon 1,2 enrichment consistent with biological or synthetic processes. The probability of all three occurring together by chance is 1 in 4.7 billion. And the data stream is still active. By 17 UTC, every major observatory had confirmed the findings. The methane flow continued at 300 kilograms per second. The energy output remained stable. The isotopic ratio held steady. Then at 1830 UTC, the Jet Propulsion Laboratory identified something new. The gas jet was rotating, but not randomly. It was locked in orientation, pointing directly away from the sun. Most comets tumble unpredictably, spinning along irregular axes. The methane plume from 3I Atlas was aligned with precision. At 1842 UTC, Goldstone's Deep Space Network antenna detected a Doppler shift indicating gas ejection at 2.4 kilometers per second. That speed exceeds the object's escape velocity. This is not a diffuse cloud. It is a focused exhaust stream. Direction matters. Because the jet points away from the sun, it acts as a retrograde thruster. It slows the object down. Even a slight reduction in velocity alters orbital dynamics. Instead of continuing on a hyperbolic path that would carry it out of the solar system, the deceleration could shift it into an elliptical orbit. At 1915, UTC Orbital Dynamics teams recalculated the trajectory. If the current thrust continues for 3 days, 3I Atlas could lose 400 meters per second of velocity. That adjustment would lower its perihelion to 0.8 astronomical units from the Sunday. That distance lies within the habitable zone where liquid water can exist. In nature, rocks do not perform orbital insertion maneuvers. Gravity shapes their paths. Random gas release does not align precisely to produce controlled deceleration, yet the thrust vector remains aligned. The output remains constant. The trajectory is changing in measurable increments. The probability of a natural object venting gas in the exact direction required to slow itself into the inner solar system is effectively zero. Still, the data shows a sustained retrograde burn. We are observing measurable navigation-like behavior. The implications now move beyond chemistry and thermodynamics into orbital mechanics. And the question becomes unavoidable. If this deceleration is intentional, what destination is being targeted? Let us summarize what is confirmed. A 300 kilogram per second release of nearly pure methane, a 150 megawatt internal heat source in deep space, a carbon 1:2 enriched isotopic ratio resembling biological or laboratory processing, a collimated exhaust jet aligned for retrograde thrust. These are documented observations from NASA, ESA, and independent observatories. None are speculative. Now, consider timing. If 3I Atlas were a typical comet, it would pass near the Sun and depart along its original trajectory. Instead, it began firing a retrograde jet at a distance calculated to shift its orbit towards 0.8 astronomical units. That distance lies inside the Sun's habitable zone. It overlaps Earth's orbital region. Orbital mechanics is precise. Entering a stable elliptical orbit requires reducing velocity at the correct vector and at the correct time, too early or too late, and the object escapes or crashes inward. The current deceleration curve aligns with an insertion window that becomes critical within 72 hours. Scientific institutions are cautious. They describe the event as anomalous. They avoid speculation about intent. Yet data does not carry emotion. It records motion, energy, and composition. Those values now show an object actively altering its path toward the inner solar system. There are only two possibilities. First, this is an entirely new form of cometary physics, one that produces sustained energy, refined chemical output, isotopic anomalies, and directional thrust. If so, textbooks must be rewritten. Second, the deceleration represents controlled orbital adjustment by a technological object. There is no intermediate explanation that satisfies all measured variables simultaneously. The probability calculations narrow the field. Either our models are incomplete or something unprecedented is unfolding. As you watch this, the Deep Space Network continues tracking the deceleration curve. Every hour reduces uncertainty. In 3 days, the trajectory will confirm whether 3I Atlas transitions into a stable orbit or resumes escape velocity. The instruments are active. The data stream continues. And the object is still slowing down. If the deceleration continues, 3I Atlas will approach its calculated insertion point within 72 hours. That window determines whether the object remains gravitationally bound to the Sunday, the thrust output remains constant, the methane jet remains aligned. Orbital models update in real time with each telemetry packet received. Scientists are not driven by speculation, they are driven by measurement. At this moment, measurement shows sustained propulsion-like behavior. It shows refined chemical processing inconsistent with known cometary composition. It shows isotopic ratios associated with advanced chemistry. These observations are either revealing a fundamental gap in our understanding of small body physics or documenting the arrival of a technological object. If this is natural, then we have discovered a process capable of generating reactor-level heat in deep space, separating methane to near industrial purity, and aligning gas release with orbital precision. That would represent the most significant shift in planetary science in decades. If it is not natural, then 3I Atlas is not a passive traveler, it is an active participant in its own trajectory. The distinction matters because 0.8 astronomical units places it within the same orbital region as Earth. Any stable insertion would allow continued observation, close study, and possibly interaction within the inner solar system. The next 72 hours will provide clarity. Either the thrust fades and the object resumes escape, or the deceleration stabilizes into orbit. There is no room for ambiguity in orbital mechanics. The math will resolve it. Right now, telescopes remain locked on target. The Deep Space Network tracks velocity changes minute by minute. The methane plume continues at 300 kilograms per second. The engine, whatever its origin, is still active. We are witnessing an event that forces a choice between rewriting physics or redefining our expectations about what moves through our solar system. Stay with this channel for verified updates as the data unfolds, and subscribe now so you do not miss the moment when the final trajectory confirms what 3I Atlas truly is.